should I choose a container over a full operating system? You know, in years of working in the world of operations and deployment, I've thought about the complexity that goes behind managing operating systems. And let me tell you, between storage, between all the patching, security, network intrusions, you name it, it's just a lot more work. If you're simply needing a runtime to have your application run, there's no need for you to run an entire operating system, manage a kernel, and ensure all those other extra packages are managed. Let's move beyond that. Let's simplify life. A container will just provide you with the runtime you may need, and then you can go ahead, add any additional dependencies, and then make sure your application runs. So it's about reducing how much work you as a developer or maybe an operations person have to do, and really improving how quickly you can work. So less mess, less fuss, and more creating. And that's really the big key. We say containers over maybe a full virtual machine because it's going to give you the added control, simplicity, and ultimately the ease of deployment for your application. Welcome back, welcome back, welcome back. My name is Jay Gordon. Every week we get together here on AzureFunBytes. And what do? Well, we talk about the products, foundations, and fundamentals that make up Azure. And we also love to talk about complementary products from other vendors that can help you get the best experience. Because let's face it, there's so much that you need to kind of keep your mind on when you're building applications in the cloud, and you may need some extra help. And so there's a lot of great vendors out there that produce products that can just help you either get more out of your Azure deployment, or provide you with additional information that you need. You name it. There's so many different companies out there that do great stuff. And so today, I've got a guest from a really cool company called Gremlin. And we're going to talk about Gremlin today. We're going to talk about what they provide and what they do. But the big thing that the big thing that they provide is an ability to create a chaos engineering as a service. And so let's talk about that for a second. So we're going to watch this, and then I'm going to bring our guest in.
Gremlin helps engineers build more resilient software. It provides a platform to run chaos engineering experiments in a safe, simple, and secure way. Here, you can see the Gremlin web app where a network latency attack is being run against several containers. Let's take a step back and take a look at some of the key components of Gremlin. With Gremlin, you can thoughtfully inject failure into hosts or containers regardless of where they are, whether that's the public cloud or your own data center. After you've installed Gremlin's lightweight agent on your hosts or containers, you can then inject failure across 11 different infrastructure attack modes, or gremlins. Infrastructure layer gremlins fall into one of three categories: resource, state, and network. Resource gremlins allow you to consume specified amounts of CPU, disk, I/O, and RAM. State gremlins let you manipulate system time, shut down or restart hosts, and kill processes. Finally, network gremlins can inject latency to requests, introduce packet loss, or drop the traffic altogether. You can also simulate a DNS failure by blocking access to DNS servers. In addition to infrastructure layer gremlins, you can inject failure at the application layer using Gremlin's Alfie library. Attacks can be configured, started, and stopped via the web app, API, or CLI. Safety is a core design principle for Gremlin. You can precisely target the blast radius you want to attack, and should issues arise, all attacks can be immediately halted, rolling your system back to steady state. Get a closer look at Gremlin by creating your free account at gremlin.com. You'll also find our docs and quick start installation guides specific to your environment.
And with that, look, I have my guest. It's Anna Medina. How thankful I am to have you today here on the show. How are you?
Good. Thank you very much, Jay, for having me. I'm very excited to be here and talking about chaos engineering and stuff. It's a pretty good Thursday. I think that's what day we're on.
Yeah. Sometimes I have a hard time keeping up myself, but here we are. It's Thursday every week around 11 a.m. On the Pacific, where you're at, and here on the East Coast, where my heart and home is, at 2 p.m. What we do is we get together and I talk to people about things that help make Azure great, all the fundamentals. And like I said, there's a lot of great products out there, and I think that Gremlin, who I've met a bunch of you before. I've met your founder, Colton, years ago. I really appreciated, all the things that you all were doing, because I think one of the things we'll talk about today is why chaos engineering is so important, especially when you're talking about complex applications and distribution of those applications and the different services that people need to attack to find out whether or not they are resilient.
Definitely. Yeah, it's been awesome. I've been at Gremlin now for almost 3 years. Been working in chaos engineering for 5 years, and it's been great to see the space of chaos engineering grow in like the last few years, but specifically in the last year, we're starting to really see that momentum, and people start shifting and asking, how do I actually do this, instead of asking, why should I care about this?
Gotcha. So I know that there's a lot more to learn, and we're going to get to that. But one of the things I'd like to remind everybody of is that we always take a poll here on Azure FunBytes. I love to get information about what our audience is interested in. And so I'm asking you today, um, are you currently practicing chaos engineering tests in your application environment? I know, Anna, you and I want to find out what the viewers are up to and if they are taking part in this type of process. And that being said, we need your questions. If you have questions about chaos engineering or just about how rad Anna is, I'm sure that we can do our best to answer them. So head over and answer our poll. So Anna, before we get too deep into the weeds, I really just wanted to ask you, how'd you get here?
How did I get here? Let's see. Born and raised in Costa Rica, eventually got into the United States, came out to Miami, and I started coding at a really young age, and that led for me to learn about how do you build websites, how do you do backend. I also transitioned to an iOS Android development, and then I got my foot into the door into systems and ops by being a site reliability engineer. I joined Uber and I started doing chaos engineering there.
Mhm.
And that's when it was like, oh, this is my first time learning systems and ops. But if I'm able to learn them by breaking them apart, things
Mhm.
started clicking more for me. And I later transitioned to cloud infrastructure, trying to go from bare metals to multi-cloud environments that were vendor agnostic. So when Gremlin came up as an opportunity, it was like, wait, no, like I do love cloud infrastructure, but a lot of things made a lot more sense for me in the chaos engineering space. It was pretty easy for me to like dive into it. And I just have a passion for learning and educating and community. So it kind of has been like a really nice sweet spot for the last 3 years where I kind of focus on building the chaos engineering community, helping customers and prospects adopt the chaos engineering practice, from looking at architecture models and thinking about experiments to, wait, no, we need to come up with some action items to make this sort of application a little bit more reliable.
Yeah, that all makes a ton of sense. And to be real, it really comes off how much you care about this particular community and sharing these ideas. It really comes across that way. And so I've always been a big fan of yours. We met some years ago, and I know some amazing people you work with, like Tammy Buto, and someone I worked with years ago as well, Jason Yee. He's another great person. You've got just a huge team. I should say a good team of huge talent, a great
Yes.
team of huge talent, and that talent is visible to all of us because of all these different things that you produce. And so, I'm going to be honest. I've worked around Azure a bunch, and I've created lots of failure on my own. And I think that that's kind of what it comes down to sometimes is you find your own failure, and unfortunately, it isn't always at the right time. And so, you know what, Anna, I always like to first tell people about like the big idea here. And I'm going to let you kind of get into it, but I want to go to the big fundamentals because, like I say, fundamentals are what we talk about. And so I wanted to bring up this thing right here. It's the principles of chaos engineering, and I feel like this is basically the big heart of where all this begins. And so I'll give you a chance to talk to me a little bit more about it. But if you want to read this full manifesto or this paper, you can head over to principlesofchaos.org. I've seen some of really interesting stuff around this. And so just to say, chaos engineering is the discipline of experimenting on a system in order to build confidence. And that's a big word right there, in the system's capability to withstand turbulent conditions in production. And so one of the things that I really believe, and I've said this a lot to some people, is that if we've learned anything in the last, like, say, 12 months of being alive on this planet, it's that the best possible plans that you make sometimes can get just thrown completely out. And so I believe it becomes really important to be able to pivot, to on the fly make decisions, to be able to react. But being proactive tends to be a little bit better. And so I feel like, and you can tell me, is chaos engineering really about being proactive?
Yes, 100%. And it's instead of reacting to things that come up, to the failures as they're happening at 1 in the morning, 4 in the morning, you get to be proactive and you think about those failures when you've had your coffee, when your team is online, when you don't have 20 projects going on. So you get to really put that proactive approach of, we haven't had this incident happened, but let's be proactive about it and come up with those questions. If we were to have these failures happen in our database, in our messaging queue, how would our application react? But also, what does that look like for the customer? Since a lot of the reliability focused work is making sure that our customer trust is always high. And that comes in many ways.
Yeah, reputation to me, and it's interesting. I was talking to someone last night, and we talked a little bit about reputation. For your applications, for the systems that people rely on, whether it's internally, if someone is supposed to be able to log a certain amount of information every single day, they might be used to an application that's internal to the company that's always working, and it may be something absolutely huge. And at the same time, externally, there could be applications that people are using to do things like stores. And you and I, we've worked around with a demo e-commerce site before that shows what happens that if you go and you inject some chaos, sometimes it happens without us expecting. You can find out that certain things that you planned aren't necessarily going to happen.
Yeah, and we'll get a chance to look at a little bit of that shop later on. But to your earlier point, where the last year has taught us a lot of that, I think in the space of engineering and in software, we've seen a lot of companies kind of wake up and it's like, oh no, now we don't have stores, we don't have financial institutions to walk into when you need to deal with things. And across the globe, everyone is relying on these online systems to be up, not just for like the things that they want, but for the things that they need. So it has become a necessity for reliability to be prioritized by organizations. And I also love that part that you mentioned, that is not about those external systems always. We also have to treat our internal systems as making sure that we are providing that experience as well.
Yeah, because we have SLAs internally, or we should have SLAs internally that will allow us to treat internal applications as just as important as external ones. Especially if you're in an ops department, DevOps department, whatever you want to call it, and people from, say, leadership are having expectations to be able to get to certain things. The moment those things become more difficult for them, it also hinders it hinders the actual reputation of an internal ops and dev team too. So it's not just about, external perception, which is, super important, but the idea that, we've got things in-house that need to work. And so you can think about some of the biggest companies in the world that have, really important applications to themselves, and the fact that these are things that they should be doing too.
And I mean, I think all of us have important internal applications, like especially in this digital world. But it's like things like whether it's your CI/CD, your monitoring, or even your instant messaging for your day-to-day communication with an organization. It's even looking at those of, if those were to fail, like, do we have processes written out of how we bring them back up, the failover techniques if we need to transition to another protocol or like process.
Yeah, it makes a ton of sense. And so I want everybody to kind of know that, these things, we're going to hit on some of them today. We're going to talk a little bit about chaos engineering. We're going to take a look at how to actually apply some of these principles to an Azure deployment. But I want everybody to remember, I wanted everybody to know, I should say, not remember, because I haven't told you yet, that there's actually a boot camp that you and I are going to be working on next week, March 31st. I'm going to bring it up. You can start registering today. It's going to be a chaos engineering on Azure boot camp, March 31, 10 on the Anna side, 1 on the J side. And you and I will get together. We're going to talk about the history. We're going to run some experiments. We're going to hear about the big companies that are using it. And then we'll also find out how to democratize results within your organization. And so one of the things I'd like to kind of get into first, if you don't mind, is your definition of chaos engineering. Because I know I gave everybody the industry version, but I'd love to hear what you think.
Yes. So my quick side of it is very much of an inject intentional failure to learn from your system to make it better on day-to-day operations, more reliable, and make those failures not have a large customer impact. If you ask the Gremlin organization what that definition actually translates into, is thoughtful planned experiments used to reveal the weakness in our systems. So it all kind of translates to injecting failure for the purpose of making things more reliable.
Yeah, and reliability ends up being something we really need in our apps, because the moment they become unavailable, they take too long. Something, like I said, it all comes back to reputation. And if I want to purchase, say, the latest, greatest video game, and I can't because the store is having some sort of huge pain point in the middle of the process, then I'm going to miss out on the video game that I want so much. And the actual business is going to miss out on the sale. And ultimately, we want to preserve value that people have in what we do. And so I think a lot about why we talk about DevOps and how these all kind of come together with chaos engineering. DevOps is about delivering value to our users. And
Yes.
without being able to quantify the failure that could occur, you have a hard time making sure that value is going to be fully delivered. And so I'm really interested in hearing a little bit more today. And of course, we're going to take questions from everybody. I wanted to remind everyone, please take our poll, head over to aka.ms, LearnTV. Let me know. And Anna, I know you are, but everyone else, are you currently practicing some chaos engineering in your testing environment? Or I should say in your production environment? There's plenty of places for you to start using it. And so, Anna, I want you to kind of help me get into things. And I know you've brought a presentation that you can start showing before we start looking at maybe some demos. So I'm going to bring up your presentation, and I'm going to let you kind of take off, if you will, because you're a great big rocket ship full of information that's going to blast off into space, and we're all going to learn so much from you.
That's so sweet, Jay. All right, there we go. So If you're just tuning in now, just wanted to touch base on what is the definition of chaos engineering? What is it that Jay and I have been talking about and are going to be talking in today's session? Well, the simple definition is that chaos engineering is a thoughtful, planned approach by designing experiments to reveal the weakness in our systems. And the really nice thing about this is that we follow the scientific method to try to craft these experiments. So we start by observing our system, whether it's an architecture diagram, trying to see how our microservices talk to one another. We do go ahead and baseline our metrics from understanding how does our system behave in normal conditions to looking at those service level indicators, service level objectives for each portion of our application. Then we go ahead and we form the hypothesis. If I lose a host in my application, I expect my application to be reliable. If I inject a 10% resource consumption on the CPU layer, I expect my monitoring to show up on it, but I also expect my application to handle it in an okay manner. And then you also have to come up with the abort conditions. Abort conditions are those things that would cause for you to stop an experiment. So we always keep safety in mind when we do these experiments. An abort condition can be something like my application is unresponsive, to my response rate is really high, the error rate is really high. And you go ahead and you define where you're going to run that, whether it's a node, whether it's a service, a 10% of your deployment. And you go ahead and you run that experiment that the blast radius is going to be defined as the surface area, and that magnitude is going to be defined as 10% increase of CPU, 100 milliseconds of latency. And as you run those experiments, you want to make sure to look at how is your application behaving as these experiments are going on, whether it's looking at your monitoring, making sure that your user can use the application, or any of those upstream and downstream dependencies are actually handling these failures in a pretty okay manner. And you want to make sure to also figure out if you want to expand that experiment, if that experiment was successful. But if it wasn't successful, that's okay. Go ahead and make it more reliable, go put some changes in, and then run this experiment again. Part of it is that you want to get comfortable and grow the experiments out. And this is also the same matter that we look at chaos engineering as a whole. Don't go ahead and start out in production trying to hit 50% of your hosts. Start out in a really small matter, whether it's just 10% of your hosts. But the other thing that we say is don't start in production. Start out in those lower level tiers of environments that you may have. So testing, Q&A, staging.
Taking baby steps.
Yes. Yeah, a lot of this is learn how to crawl, learn how to walk before you go ahead and run, because you want to be thoughtful. You want to plan this out. And the purpose is not to break production. We're trying to make everything more reliable for the purpose of our customer trust too. And that last step with chaos engineering is what I say one of my favorite ones, where we're sharing those results. Share what you learn with the injection of failure to your team, to your leadership team. And I always say, take it a step further and write a blog post. Talk about it in your developer community. Like, what is it that you learned as you injected some failure into your MySQL deployment, into your Redis cluster, into your new Kubernetes 1.20 deployment? Like, be really specific and be like, oh, I injected such failure and everything worked out well. Or we injected such failure and everything blew up. Like, there's so much things that one can learn from others' failures, and we can all as a community learn together.
Absolutely. And I think that this comment was really, really great. You know, it makes a lot of sense. As regular features, we start with lower environments. And sure, yeah, we want to get started in dev or test or whatever it is in prod before we hit prod, because ultimately we want to be able to do everything in a kind of a controlled fashion, if I'm right. And so if we, start small and really think about things in a really, really what's the word I'm trying to think? If we're thoughtful about how we begin this process, then what we're going to do is avoid, destroying things that we need in real time without being prepared for it. And so, I know that there are like game days and different roles, and I know we'll talk a little bit more about that. I just wanted everybody to remember, and I'm going to keep bringing it up to everybody because that's what I do. Take our poll, be part of this. Are you practicing chaos engineering in your app environment? Let us know. And aside from that, and I wanted everybody to also know that they can put their questions and comments like we just had below in the chat because we want to hear from you. So I'm going to bring it back to you, Anna, and let you kind of do your thing.
Yes, thanks, Jay. And one of the things that kind of came up as we were talking about this and where to run your experiments is that a big reason why we do this is that when these failures occur, we suffer downtime. And downtime is extremely expensive, whether it's due to brand reputation or your engineers burning out, or whether it's something as simple as you broke some service level agreements, so you have to pay those customers back. But it also just comes into this really expensive bucket as we try to quantify it all. And there's some portions of it that are not going to be quantifiable. And as we look at that number, it's estimated that every company loses around $300,000 per hour that they're down. And that's on a regular day-to-day business day. That's not including when there's high traffic events, peak traffic, a big sale going on. So that number continues growing exponentially. And a big reason why we do this is that we want to reduce that cost. We want to make the length of those incidents a lot smaller. But at the end of the day, we want to reduce those incidents from happening. We want to inject the failure and know what happens when these failures occur on our own terms, so that we don't get woken up at 4 a.m. of, hey, we can't reach your API. Your entire database where your images are stored are unreachable. Like, you have to go figure that out at 4 a.m. It might take you 20, 30, an hour longer than it would if you have done this when you've had your caffeine. You can ping someone else, you can escalate. So that is like one of the things that I want to make sure that kind of came across, the reason and focus why we do this. And leading on to it, one of the things I wanted to call out is you might be sitting here, you might be like, I haven't done chaos engineering. We want to, but we don't want to. Like, we can't because we don't have time. And that's very much where you're already spending that time firefighting. You already are prioritizing other things. You're prioritizing features on product enhancements over something as simple as reliability. And what I say is, what is more important than making sure that your business is up and reliable and available and you keep that customer trust high?
Oh, absolutely. Like we want to retain our customers. We want to avoid handing out SLA credits. We want to avoid doing these things that damage reputation. And so we continue to find better ways of preserving that uptime, because you know what? I've been on call, Anna, and let me tell you, one of the things I remember the most from being on call is getting hit with outages that really had no explanation. And, it would just be a thing that happened. And I really would, it would actually impact me personally, because, it would be, 1, 2 in the morning, or maybe I was out and about with friends at dinner or something like that. And then I would have to put all of my focus on something that was a complete mystery to me. And I think that there's some psychological safety in being able to not necessarily be thrown to the wolves every single time we run into a problem. You know what I mean?
I think, yeah, every single time makes it really hard. But even with any sort of on-call rotation, like, you shouldn't just be thrown into the wolves. Like, I got onboarded to on-call with, here's your PagerDuty account, here's the run book, you're smart, you'll figure it out. And when that first page came in ever, it was very much of like, all right, I think I know what I'm doing in order to resolve this incident. But you're kind of unsafe. So you're still like, am I going to lose my job tomorrow? Like, I didn't really have anyone I could escalate to at that moment. and it's at 3 a.m. So I'm already going to walk into work extremely cranky the next day. So part of it is making sure that we're being thoughtful about how we onboard engineers to on-call, whether it's their first rotation, whether they're transitioning teams, whether they're gaining more leadership in the organization that they have to learn more. And it's also that, why should I be onboarded to on-call with the run book that's 300 days old? Why can't we be running exercises for us to update those documents, and whether things are getting automated, or just give me more of that safety blanket of I'm gonna do the right thing because we verified a lot of this.
And you used that word that I mentioned before, and that was thoughtfulness. If we're being thoughtful, not just about us and or what we're doing, that translates of that thoughtfulness to other users or other developers, other ops people that are going to be, either using these applications or responsible for actually keeping them online. And so, so I think that we're talking less and less about, just this isn't about just going in and randomly turning things off and saying, "Whoa, wow, what happened?" This is more about making decisions about how failure would occur and to avoid it beforehand.
Yes. And it's that about that thoughtful approach, but you also want to be like, what part of my application do I really need to care about? Those critical services, the things that would cause step zero incidents, those things that would really affect our customers. Make sure that you're injecting failure there. But it goes back into crawling and walking before you can run. Go ahead and start injecting failure at those services, but on lower tiers or really smaller experiments if you don't have other environments. Because those are where, when the outage happens, it's going to cost you a lot of money. And that's where you go be thoughtful and you plan it out.
And I think the one thing that we can kind of think about here is that if we're being thoughtful, we're not creating things as too static. We should be able to have a certain portion of our application underlying systems that can take a hit and not completely devastate our workflow. The things that we're expecting to happen every single time. And I think that elasticity in the cloud has lent itself to be able to make this type of practice far more common.
And it's kind of funny because you mentioned that, because it brings me to the next excuse of we don't need to break things because they're already breaking on their own, where it's like, I onboarded to the cloud, I'm reliable, I have containerization and Kubernetes, I'm double reliable. Like, these are the things I hear on a day-to-day matter. And it's like, why is it that we should do something like this? And it goes back to that moment where it's about timing. Things are breaking not on your terms. You're seeing cascading failures that you have no control over, that you're not thoughtful about. So wouldn't you want to go do this on your own terms so you can have the right documentation, the right links, the right people to escalate to or debug with?
I like this comment that we got here. Thanks, TRP8472. I think a number of clients at the Min barely struggle to run what they have while they're looking. Well, this person's looking at this, and got a little funny on-call story. If you go into the chat, you could take a look at it. But everybody's got those little on-call stories for when, even at small client levels, you don't always know in certain situations where the single points of failure exist. And sometimes they will just present themselves. They will break on their own. They'll give us an opportunity to do real-time chaos engineering, as opposed to some of the things that you're going to, keep going and showing us. And we've got a good, we got about 25 minutes left in the show. It goes so fast, right? And so make sure we get your questions, and this is a great point. No matter how simple or complex, the basic steps are always important, and that's observability, monitoring, and testing.
And on that note, it goes back into that of going and injecting your chaos engineering experiments in a proactive manner. But that includes things of what happens if my monitoring goes down, or what happens if I can't reach one of the most critical portions of our application, whether it's an API, a database, those things that are really going to make an entire service work for a customer.
Gotcha. Yeah, and I think these are that the proactive term ends up becoming something that I think really becomes important, because we talk about that a lot in also SRE, because SRE in itself, site reliability engineering, ends up being a practice that I feel is well, we can look at it as a replacement for the way ops used to just work. It's not necessarily that. We're actually fixing things before they break by continuously improving, by continuously educating ourselves on where everything is. And I think that this is a big part of that, this testing proactively.
Yeah, it's very much about taking everything we learned from DevOps and putting a focus on reliability and making sure that that culture change happens with it, where you need all your engineers and more to care about reliability. As a company, you need to care about customers and make sure that that customer trust doesn't go down.
Oh, absolutely. I completely agree with you. And I'm really excited to see what else you got for me.
Yeah, I brought in some AKS experiments that we can talk about, and then we can actually run one of them. So one of my first experiments is that where we already onboarded to Kubernetes. I was
Mhm.
about to call it something apparently different. So now that we onboarded, we think that everything is going to be reliable because that's what Kubernetes promises. We kill a container, we kill a pod, Kubernetes got our back. It's going to be back up and running. So what actually happens when one of our pods or replicas actually dies? And that's when a lot of people don't know. Their answer is Kubernetes will bring it back up. So
Mhm.
when we're thinking about experiments like this, you go ahead and you run an experiment of shutting down that pod. And that's when you take a moment to observe whether it's in the baseline metrics, the user experience, how did your application react to it? And you can actually see some conclusions of your application is completely seamless, nothing ever happened, or we can see some things actually fail. And we can actually take a moment to do that experiment while we're at it.
Sure.
So let me pull up our demo environment. So this is actually a sneak peek into the demo environment Jay and I will be using 7 days from now in our workshop.
And once again,
And
here's let's both point down. That's where you can go to
join
register.
us.
Head to that URL when you're done with the show. When you're done with the show, we got to finish this up. But yeah, so you've got this. I think we like to call it hipster shop. It's a really good common e-commerce demo platform that you can play around with. We've also got one in Microsoft for Tailwind traders. There's all types of different ones. This is just another.
Yeah, and it's very hipster. You're paying $13 for a camera lens. You're paying, what was it, almost $800 for a bike.
Mm-hmm.
And it's interesting, but it's that where we get to see that the customer experience is pretty seamless. Things are loading really quick. I can go ahead and add something to my cart and I can place my order. So one of the things we wanted to do is look
And this is
at
all busted up into, I'm sorry, this is all busted up into, say, microservices, if I'm right. So there's a
yes.
ton of different services that are in their own kind of set of pods in Kubernetes that allow us to kind of isolate them so they're not so tightly coupled. They're loosely coupled so that you can allow one certain portion to fail and it won't destroy everything else. And it's up to you to ensure that, if checkout service dies, that you're still going to be able to, say, have the front end on.
Yes. So this is that handy dandy architecture diagram that you're kind of referring to, where we're able to see, yeah, checkout service dies. Maybe we should still have another way that those things are actually saved. or we think that those some applications like ad service or payment service, shipping service might not be the most critical.
Mm-hmm.
It all kind of depends on what is your business actually getting out of it. And the one that I wanted to touch base on is that we have a Redis layer that is just a cache, right? If our caching layer fails or has to shut down for a moment, we should be okay, right? So I want to go through and just shut down my Redis container. What happens if my Redis container dies? We still have our card service that should be storing all of our data. So I'm going to head on over to Gremlin. We're at our dashboard. I can see that I have deployed this on 2 Kubernetes clusters. So we actually have it installed in 6 clients because we have 2 demo environments today. I head on over quickly to attacks. I'm just going to do one simple attack to get started.
Mm-hmm.
When I can create a new attack, I have the ability to target the host, the container, or the Kubernetes layer. For this one, I'm going to go over to containers. And the nice thing is that I can just look up my container by the name of it. So this container is just called Redis cart. I've selected it via the tag, and we can see that it's just one container running on the 86 that I have, and it's only on one host. So that is that blast radius. We're going to be targeting one of those one containers. I now get to choose that gremlin. We can inject chaos on the resource layer, the state layer, or the network layer. We're going to be going on the state layer and doing that, where we are just shutting down immediately that container.
I love
And we don't.
Killer's logo, by the way. I like that very much.
Yes.
I got a couple skulls tattooed on me myself, so I'm always interested in little skull icons. I like that a lot.
Yeah, we can get you this one as a little next tattoo if you ever want it. But yes, we're gonna be just shutting down that Redis container. We won't have it reboot because we want to test that. Will Kubernetes bring it back up when it gets announced again? How long does it take? How does it react? We're just gonna unleash that gremlin. We'll see that gremlin has a pending. We'll go back to our demo environment just to start seeing how our application is behaving as this failure is about to occur. We're trying to place our order, which a lot of this touches those things. And we want to continue browsing. We add more things to the cart. We place our order. And it's that. Our application was reliable enough that we shut down our Redis cart and we didn't see anything. We saw that the application was okay. That means that Kubernetes kept its promise, right? We
Sure.
were able to keep things up and running. That was a failure that did not have an interruption to the users. And that's how we want to build things, where things can die, come back up, and our users don't see any failure.
And what's great is that Azure provides you with a lot of monitoring built into the AKS cluster. So if you actually go into, thank you so much. If you go into this section, you'll see that there's a number of different ways to use Azure Monitor, application insights, things like that allow you to kind of keep your eyes on the prize when it comes to your containers. This is a great view. I'm going to make it a little bigger for everybody. But you can monitor your infrastructure with Kubernetes. You can go in, take a look at pods. You can look at the specific cluster nodes and make decisions on what parts of your application were responding the best or the poorest. And so I really love all this tooling. There's no need to go to someone else. If you want to, that's fine. But we've got it right now built into Azure so you can start looking at stuff. So what else you got for me, Anna? We got about 15 minutes left.
Yeah, let's see. We'll be able to talk through this one just because it's pretty simple. Where as we've looked at the Kubernetes environments grow and we just see cloud infrastructure in general, we see that a lot of companies just trust that they set up auto-scaling properly, where you're very much of like, oh, we're launching something new. Auto-scaling is set up. We have everything ready to go. As more new users are hitting our site to try to check out with the new shoes, we're good. And It's that part where you don't know if auto scaling has been set up properly unless you're actually testing those conditions proactively. So as we looked in 2019, what the most common failures of Kubernetes were, this one was one of the most important ones. And even in January, we saw Slack have a huge outage as the United States came back on board and January 4th to work. And as they wrote the postmortem, that was actually super interesting to read, where they actually provisioned auto-scaling to work properly. But as they're leveraging their cloud provider to do this, it actually ended up taking longer to have those nodes start showing up in the rest of their environment. And that actually led to this large over 1 hour outage where a lot of customers were impacted. And you want to be proactive about it. You want to make sure that as you set up those auto scaling policies, you are validating them. You're making sure that those resource limits, where if you're in containers or if you're in just regular environments, you're able to see that those nodes come back on, that they're able to join their environments, that they're starting to serve traffic. The load balancer has been added to it, that we're also seeing it start just being seamless into the application, the same way that you've kind of tried leveraging it. And that kind of just leads to more things that you can do, where now you're thinking about the infrastructure is set, but how is it that we can actually make sure that this is a really great experience for our users? And that's where latency comes in, or anything on the networking layer, whether it's packet loss or just blocking off the traffic to a container or port. You want to ask, what actually happens when my application can't reach my API, that data store, or our other third-party vendor that it's serving us all these other tooling that we have? When that becomes unusable, how is our customers and our users affected? So you can easily replicate that by using some of those gremlins. And we can do that with Gremlin. I want to call out what service I want to target first. So we see that we have this little advertisement service that it's serving us deals. You might consider this a critical service because a lot of revenue comes through ads, or you might just think this ad service is just being put on at the bottom of our item pages, so it's not as important. But let's say this is how all of our revenue comes in, and we really want to make sure that if ads stop working, our application is still usable. So we can easily do that various ways. I'm going to go ahead and do this on the Kubernetes layer so we can see this offering too. On the Kubernetes layer, we're able to narrow down the cluster. We're able to define that namespace that we want to run it on and those deployments. So we're just going to be targeting the ad service as one pod. We'll see that blast radius visualized. We'll choose that gremlin. And what I'm going to do is that I'm actually going to do packet loss. We're going to be just dropping some of those packets. We get to define what we drop and the length of it. So for 60 seconds, I want to go ahead and drop 60% of the packets to my ad service application. So that just means that sometimes I'll see my ad service, sometimes I won't. We'll go ahead and unleash that experiment. So my hypothesis is that my application is usable. Sometimes I won't see ads and sometimes I will. So as we start browsing to it, we can see ads are being served on that page. We'll continue browsing around. We still see some ads. Film camera. They're being, like, the packets are coming in. We're seeing that the application is starting to resolve and will be running shortly too. But you're able to really take apart those dependencies that you might have, and you might be able to ask yourself, is this critical to my demo environment, to my user experience, to the architecture diagram, or is it not? That if it actually fails, things are still usable for our customers.
Gotcha. And so I want everyone to take a second, because I want to give you a moment to breathe in. You've given me so much. Go ahead. Take our poll today. Are you currently practicing chaos engineering tests in your application environment? And if you are, let us know. And the one thing that we do have a really cool question. and I wanted to bring it up for you because I think that you might find this something that you can answer pretty easily, which is, should it be part of a pipeline, and where we provision the environment, deploy the code, unleash gremlins, and run a load test? Does that make sense? So I guess the question is like, can we put this a part of our release pipeline? Should we do that, or should we make this a separate process?
No, this should totally be part of the DevOps pipeline. And I'm trying to log into Azure DevOps so I can actually show you what that looks like.
Sure. That makes a lot of sense. And hey, everybody, we've got about 10 minutes left in this incredible session, and I want you to be able to make sure that you get your question in too. So go ahead, head down to the chat, send us your questions, answer the poll, whatever you got to do. We're loving what you're doing.
Sweet. So you can put this as part of the pipeline as you're building those artifacts. And we can see that I have this on another cluster that I have built on here. You'll see that we can edit our pipeline. And in my pipeline, I am calling in that run a chaos engineering experiment. So you can easily start building it into your development. As you're developing this, how do I make sure I'm not regressing to past failures? But how is it that we can be more proactive about it? And the way we can be more proactive about it is by putting it in that CI/CD, coming into the continuous delivery, where you start running chaos engineering in development. So after we've gone ahead and deployed our Azure SQL, our deployments, we go ahead and we unleash that experiment. The nice thing is that everything I showed you within Gremlin, you can leverage through the API. So you'll see on here that I am leveraging just the CLI script with the curl command, and you're able to just run that. I got lazy and I left my API key on it, so we'll ignore it. I'll rotate it. And you'll see that after that was to pass, we will be able to have this get promoted to test. And after it gets promoted to staging, I've also put in a pre-deployment condition. And putting this pre-deployment condition before it got to staging was that it allowed for me to wait 10 minutes. So it allows for us to observe. Let's make sure that as things are starting to roll out, our application is reliable. And before it gets to prod, I went ahead and I put another pre-deployment approval just in case you need to really have those guardrails in place in your organization. And this is going to be that it won't deploy to prod unless you have a manual approval. So it really does depend on how your organization wants to tackle the implementation of chaos engineering. We understand that more organizations need safety guardrails to do this. So with putting it into your pipelines, it's needed. And it's needed because we want to make sure that we are bringing it all together. And that's when you automate the chaos engineering experiments and testing development, you're starting to walk. You're starting to get ready to run. You're getting closer to that marathon. And that end goal is that you have it automated across all your critical services in production.
And so this is a thing that I wanted, if you don't mind, to kind of touch upon for a second, is that, you mentioned you want to make sure you're doing this all in some sort of controlled environment, have some guardrails up. So can you kind of give me an idea of what a game day is in the context of chaos engineering?
Yes. So a game day is that time that you come together with your team and your organization. You do 2 to 3 chaos engineering experiments, and you're going to be pulling up that architecture diagram. You get to talk about any tribal knowledge that you have in that space, because this is where you start sharing mental models with the organization. And then you start coming up with those hypotheses. You go through that scientific method process I went through, and you learn on whether you run these experiments or whether you just get to the hypothesis portion of it. We've seen a lot of customers get so excited that they end up running 4 to 5 experiments in one game day session, or they actually just get a chance to really dive deep into those mental models and sharing that tribal knowledge. And you also come up with those action items, because a key portion of chaos engineering is making your systems more reliable. So put in those action items, make sure that they're prioritized by your organization, by your PMs, so that now, like, the knowledge that you've spent time curating, you're actually using that knowledge to make your application and system more reliable.
Democratizing it, as you said, getting it out there, making it visible, being certain that people have access to it, so that when we need to make determinations on why things happen, how they happen, the data exists. We don't have to go searching for it. And so, speaking of existing data, since we're only got about maybe 5-6 minutes left, why don't we see the kind of data we collected today and take a look at the results of our poll? What do you say?
Yeah, let's do it.
So we've got 14% saying yes, they are doing some sort of chaos engineering. 71% said no, and I think that's it's something that I think people are still working to understand, to grok, if we say here in tech sometimes. And then, of course, my other 14%, it is one of my favorite categories to always put in these polls. It's complicated. And I think go
I was going to say, you work in tech when the answer it's complicated or it depends.
Yeah, I feel like we say that a lot in tech. We always say, sure, we can do that, but it's complicated. So I'm fairly used to that kind of answer for certain things. And so I always like to give people that opportunity, because not everything in technology is cut and dry. There's a lot of things, there's a lot of shades of gray that we can run into along the way. And it's important for us to, like I said, to ask those questions. And, sometimes it is complicated. So speaking of things that aren't complicated, I love stickers for my laptop. I love stickers for, I've got my filing cabinet with all sorts of band stickers and stuff. And I went to one of your events, but when we did in-person events, I went to Chaos Conf. Yeah, I miss seeing you in person, I won't lie. We were supposed to get together, I think it was sometime last year, and it just didn't come together.
February.
Yeah.
Something like that.
But you got some stickers for people to go and check out. And look, it's even got my little website, or I should say I have my own little customized URL.
Yeah, we definitely want to thank folks that are watching this live stream at home, or where you're watching the recorded version of it too. Thank you. And part of it is that we're growing that chaos engineering community. This community is now 7,000 folks large and continues growing every single week. And one of the things that we created early on is these amazing stickers that just look like the sheets when you walk into the tattoo parlor. And I say that I want to get the terminal in my arm. Like, I will go get the terminal with the spade at some point in this year. And you get to have this sticker sheet for your phone, your AirPod case, your computer, a cabinet. So feel free to collect it by going over to gremlin.com/talk AzureFunBytes. And this will get shipped out to you as part of just us saying thank you for being part of this event today.
And also one more time. Oh, go ahead. Sorry.
No, go.
And remember, everybody, one more time, there's the boot camp. We're getting it together, and we're all getting together again, like we are today. We're going to talk. We're going to have a great time. We're going to learn. We'll run some experiments. Is there anything else you'd like to share, Anna, before we kind of get ready to say goodbye?
Yes, I have one more thing to pitch. We're putting together another virtual conference. This one's called Failover Conf, is the second version of this event. This conference is all about reliability, resilience. How do you make your teams continue being more reliable and growing them out with that psychological safety? What is it that we've learned about monitoring and observability, and what are the differences between those? So we'll be having some really cool DevOps, SRE, and cultural talks. That event is April 27, and you can head on over to failoverconf.io to sign up.
Very cool. Well, you know what? We've just about come to the end, Anna, and I just wanted to take a minute and give us a second to kind of just wrap up, say goodbye. It's been so special to be able to have this hour with you. We don't get a ton of time, this much time to talk, and I just really appreciate it. Anna, we can find you online at Anna_M_Medina. I'm going to pull it up right here. We'll find you on Twitter. We'll find you anywhere else we can so we can hear more of this awesome information. So thank you so much, Anna.
Thank you, Jay, and thank you all for watching with us today.
And everybody, we're going to give you the big wave goodbye. We're going to go ahead and we're going to let the next show here on LearnTV take over. We'll see you again next week. We're going to be talking about Power Apps with Greg. So we'll stick to the plan and keep talking about the great parts that make up Azure here on AzureFunBytes. We'll see you all next time. Bye, everybody.